In this video, you will understand what a linked list is, why we need it, and we will manually create our first linked list in C. So what exactly is a linked list? Linked list is a linear data structure where elements are stored in non-contiguous memory. And each element in the linked list is called a node. Here is an example of one node. Node contains a data and an address or a pointer to next node. Let's understand linked list with this example. Here we have three nodes. This is node 1, node 2 and node 3. Node 1 is starting at address 1000, node 2 is starting at address say 2000 and node 3 is starting at say address 3000. So to form a linked list, node 1 will hold the address of node 2, which is 2000, and node 2 should hold the address of node 3, which is 3000. And the last node must hold the address null, which points to nothing. Here the first node is called the head node. We have arrays. Then why do we need linked list? Arrays have several limitations. For example, arrays are of fixed size. When we declare array, we declare with fixed size. Int ARR of 6. Insertion in array is very expensive. For example, let's say we have array containing 6 elements. An array has 4 elements filled in. If I want to insert an element at this location, then I need to shift this 4 here and this 5 here so that I can free up this space and add new element here. Deletion in array is costly. For example, if you want to delete this first element, then you need to shift all these elements to this side. Now let's understand why linked lists are better. Unlike arrays, linked lists use dynamic memory allocation and can grow or shrink at runtime. Linked lists provide efficient insertion and deletion of elements, and it provides a better memory utilization for unknown data. We will discuss about insertion and deletion operations and memory utilization in great detail in separate video. Then why not always use linked list? Linked lists have several limitations. Linked list needs extra memory for pointers. Linked lists have poor cache locality because the nodes are scattered in the memory. CPU cannot prefetch the next element efficiently. Traversal in the linked list is slower than arrays. Now we know the background. Let's create our first linked list. Now let's create our first linked list program. Let's first understand how linked list node is represented. So linked list node is represented using the structure struct node. It contains a data element and a struct node next a next pointer which will point to the next node. This struct node next pointer is called a self-referential pointer. Let's build the linked list of three nodes. Here we have a head node, a second node and a third node. Let's dynamically allocate memory for each of these nodes. If you want to understand dynamic memory management in depth, I highly recommend you to watch my other video. I will put link in the description below. With this code now we have created three nodes, a head node, a second node and a third node. Let's initialize these nodes and build our linked list. Let's initialize head first. Head of data is 10, so we have 10 here. Head of next stores the address of second node, which means head of next will point to the second node. Similarly, let's initialize the second node. Second's data is 20 and second will point to the third node. Third of data is 30 and since third is the last node, we need to set it to null. In the next video, we'll see how to traverse a linked list and print all its content. Once linked list is used, we need to free up all the allocated space using free system call. Must remember, linked list uses dynamic memory. Node contains data and a pointer, which is a self-referential pointer. Head is the entry point of the linked list and last node should point to null. In the next video, we'll see how to traverse a linked list and print all its elements and understand the pointer movement. Thank you for watching. If you like this video, please consider subscribing.